All right. Um, Welcome back from spring break. Hopefully, this works out well for you. If you have any questions, please do reach out. I'll be on Google Hangouts a lot. You can do a video chat. That way, we can kind of work out problems together, and I can, show you with handwriting how to do stuff, and I can explain it in real time. Um, So use that Google Hangouts. If you don't know how to, send me an email and I can get it set up for you. I do miss you guys. I hope you all had a good spring break. If you want to reach out and just say hey, that'd be awesome. Just say hi and wave, and we'll hang up on the Google Hangouts. But do that, and I'll talk to you soon. So what we're doing today is we're going to be starting section 8 of chapter 3, which also happens to be the last section of chapter 3. Which is graphing piecewise functions. So what that means is a piecewise function is just like multiple graphs, pieces of multiple graphs, all on one graph. It looks difficult, but I promise you it's really not too bad. So we're just doing the first objective, which is graphing those piecewise functions. So, but before we graph, let's practice finding values of piecewise functions. So here's what a piecewise function looks like. It says, here's the function. It's 2x plus 3 if x is less than or equal to 0, and it's negative x minus 1 if x is greater than 0. So you see we've got multiple functions and pieces of those. And you'll notice x never overlaps with itself. So if x is less than or equal to 0, we use this function. If the value is bigger than 0, we use that function. So all you have to do is decide, where do these numbers lie? So the first one is 2. So 2 is the first number you're asked to find. So is 2 less than or equal to 0, or is 2 bigger than 0? Well, 2 is bigger than 0, so that means we're going to be using this piece of the function. So I'm going to write down that piece of the function, negative x minus 1, and they tell me to plug in 2 into that function. So it's going to be negative 2 minus 1, which is, of course, negative 3. So that's the value. When you plug in 2, you get negative 3. So as a coordinate, that would be 2, negative 3 if they ask you for a coordinate. The next one they say to find f of negative 6. So again, we have to determine, does negative 6 go in here or there? So is negative 6 less than or equal to 0, or is negative 6 bigger than 0? Well, negative 6 is less than or equal to 0. So that means we would be using the 2x plus 3 piece. So we're going to write down the 2x plus 3, and we're going to plug in the number given to us, which is negative 6. So that's 2 times negative 6 plus 3. Do the math there. You've got negative 12 plus 3, which is negative 9. So when we plugged in negative 6, we got negative 9 as a coordinate. That is negative 6, negative 9. The last one is to find f of 0. So here's where your symbols come into play, because 0 looks like it's part of both. Is 0 less than or equal to 0, or is 0 greater than 0? Well, it fits up here. It's less than or equal to 0. So that means we're going to be using, again, the 2x plus 3 part of that function. So 2 times 0 plus 3 is, of course, 3. When we plug in 0, we get 3. Okay? So the number tells you which part of the function you use, because this part tells you where you choose which value. So try number 2 if you want. Pause the video, check it out, see if you can get it. Otherwise, I'm going to go ahead and start on it. So pause it if you want to try it, and then we'll compare answers here now. All right, so the g function, 4. So this time, if x is greater than or equal to 0, we use this one. If x is less than 0, we use that one. So 4 is greater than or equal to 0. 4 is greater than 0. So we're going to be using the negative 4x minus 2 part. So we plug in negative 4 times 4 minus 2. So it's negative 16 minus 2, which is negative 18. As a coordinate, we plugged in 4. We got negative 18. Next one, negative 2. So is negative 2 greater than or equal to 0, or is negative 2 less than 0? Well, negative 2 is less than 0, so that means we're going to be using the x plus 1 piece. This time x is negative 2, and negative 2 plus 1 is negative 1. So as a coordinate, we plugged in negative 2, we got negative 1. And then again, 0. So is 0 less than 0, or is 0 greater than or equal to 0? Well, 0 is greater than, it's equal to 0. So that's this one. So we're going to be using that negative 4x minus 2 part. So that'd be negative 4 times 0 minus 2. 0 minus 2 is negative 2. So when we plug in 0, we got negative 2. Okay, so that's how you find the values of the piecewise function. To graph it, it's about the same type of thing. Maybe a little bit easier because you just pick the values you want. So we're going to graph these piecewise functions. We're also going to state the domain and the range. Okay, so what I would recommend is I would make two xy tables. One that represents the 2x plus 3, so it's xy table, and the other one to represent the other piece, negative x minus 1. It's xy table. Okay, and then our rules here. So this one, x has to be less than or equal to 0. This one, x has to be greater than 0. Right? That's what the rules say. So now, no matter what, whatever this number is, I'm going to pick that. So I'm going to put 0 for both of them. Okay? 0 is going to be for both of them. And then the inequality is going to tell me the numbers I have to pick. X has to be less than or equal to 0. So less than or equal to 0. So that means I could pick negative 1 and negative 2. So that's all the values I'm going to pick, just a few. And then on this one, x has to be bigger than 0. So I'm going to pick positive 1 and positive 2. And that's the numbers that I would choose. So whatever this number is, you need to put it in both graphs. And then the inequality tells you the other numbers that you would pick. And then we're just going to plug it in. So I'm not going to show as much work as I did up here. I'm going to kind of do a little bit of more mental math. So first number we plug in is 0. 2 times 0 plus 3. That's 0 plus 3. That's 3. This time we plug in negative 1. 2 times negative 1 is negative 2, and negative 2 plus 3 is positive 1. If we plug in negative 2, 2 times negative 2 is negative 4, and negative 4 plus 3 is negative 1. Okay, so that one's done. We will graph that in just a second. Let's go ahead and plug in this one. Our function is negative x minus 1. So 0. Negative 0 minus 1 is still negative 1. We plug in 1. Negative 1 minus 1 is negative 2. If we plug in 2. Negative 2 minus 1 is negative 3. Okay. Now, we've got all of that. Now there's one extra piece of information. So with this critical value, the 0 on this function, one of these graphs is going to have an open circle, meaning it's not included, and one of these is going to have a closed circle, meaning it is included. So this one is going to be closed because of the equal to symbol. So if it's less than or equal to or greater than or equal to, that is a closed circle. If it's greater than or less than, no equal to, that's going to be the open circle. So I'm going to look here and I'm going to really make sure that I remember this. So this one, the 0, because of that symbol, this is closed. And I'm always going to write that on my graphs because I don't want to forget that part. It's closed. This one, because of the greater than symbol, this one is open. It's an open circle. Okay, and I'll show you what that looks like. Okay, so let's graph this one first. 0, 3. 0, 3 is up 3. So it's going to be a nice, big, closed, filled-in circle. So always do that. And then I'll plot the other 2 points. Negative 1, 1. So that's left 1, up 1. And then left 2, down 1. Okay? And then, oh, you guys aren't going to believe this. I didn't bring a straight edge with me. What am I going to do? Here's an envelope. I'm doing this on my kitchen counter. That's a straight edge, right? So we're going to connect from that big closed circle towards the other dots and do not go past that big closed circle. So there's part of the function. That's the first piece of the piecewise function. The second one comes from this one. Now my first point is going to be a nice big open circle. So it's at 0, -1. So it's down 1. I'm going to put a nice big open circle, meaning it's not included, because that one is included, because then it wouldn't be a function if it were included. Remember that vertical line test? All right, the other 2 points, normal points, right 1, down 2, and right 2, down 3. And I'll pull out my straight edge, my envelope, and I will connect with that open circle in that direction towards the other points. So there you go. That's what a piecewise function looks like. It's 2 pieces of other functions. So it's going to have this weird space kind of between the 2 of them. All right, the domain. Well, we're also asked to state the domain and the range. So the domain are, remember, the domain are the x values. What x values can we pick? Could we pick 0? Yes. Could we pick positive numbers? Yes. Could we pick negative numbers? Yes. So the domain is typically going to be all real numbers. So that's going to be the case here. My domain is all real numbers. My range, however, this is where we have to think about this. But we've practiced this before. Remember, the range is the y values. So each of these piecewise functions are typically going to have either a high point, like in this graph, or it's going to have a low point and everything's going to go up from it. So this one has a high point because everything's going down from there. So what is that high point? Well, that is 1, 2, 3 on the y-axis. So it's going to be y and 3. Now, is it less than or equal to 3, or is it just less than 3? Well, since that's a closed circle, it's going to be less than or equal to 3, because it's everything from 3 and below. That's why it's less than. It's equal to because it's got that filled in circle. Remember, closed circle has the line underneath it. If it were an open circle up here, it would have just been the less than symbol. So, a lot of stuff going on here, but it's not too bad. Let's graph a few more. I've got quite a few examples here just because I want to make sure we're all clear. Okay, so again, I'm going to make 2 graphs, or 2 tables. Okay, my first one is going to be x is less than or equal to 0. So that would be the negative 4x minus 2 part of the xy table. And then this one is x is greater than 0. So its function is x plus 1. It's xy table. Okay, so this tells me the values I can pick. I have to pick 0 for both of them because that's the number that was listed here. And then this tells me the other numbers I can choose. This says I can choose values that are less than 0. So that's going to be -1 and -2. This one says I can choose values that are bigger than 0. So that's going to be +1 and +2. And now, all I have to do is plug in to these functions. So first I'm going to plug in 0. -4 times 0 is 0. 0 minus 2 is -2. Now this one I'm going to always highlight my first point. This because I don't want to forget. This one is, that symbol means closed. Then I'm going to go ahead and fill in the other ones. -1, so -4 times -1 is +4. 4 minus 2 is 2. And I plug in -2. -4 times -2 is +8. 8 minus 2 is 6. That one's done. Now I'll just plug it in here. 0 plus 1 is 1. And then I always remember on my first one, this one's special. So I circle it. I look at that symbol. This is an open point. Okay, don't forget that. And then I just have to fill in the other 2. 1 plus 1 is 2. 2 plus 1 is 3. Okay, and I plot those points. First one, 0, -2, a nice big closed circle. And then I've got left 1 up 2. And then I've got left 2 up 6. 2, 3, 4, 5, 6. I'm going to use my straight edge. I start at that big, bold point, and I connect it with my other 2 points. I like to use a straight edge because I like to be exact. And put that arrowhead in that direction. The other one is 0, 1. Remember, that's a big open circle. So up 1, big open circle. And then right 1, up 2. Right 2, up 3. And then pull out your straight edge. And again, connect, go in those points direction. And okay. So the domain, once again, I could pick any x value, so that's all real numbers. The range, we have to think a little bit. It's here and everything above that, right? Goes up forever. So what is that? It's above and equal to, because it's the closed circle, what is that number? -2. It's everything -2 and above. All right, let's do another one. Okay, this time, notice my values over here are 1. Okay, so I'm going to break it down and write the pieces separately. So I've got x is less than or equal to 1. The function is -x. And my xy table for it. And then my other one is x is greater than 1. Its function is 2x plus 1. The xy table for it. Okay, so what value do I have to pick for both of them? It's that number. So I have to put 1 in both of them. And then the inequality tells me the other numbers that I can choose. So these ones are values that are less than 1. So that means I would pick 0 and I would pick -1. This one says pick values that are bigger than 1. So I would pick 2 and I would pick 3. And that's enough. Then all I have to do is plug it in. This is a nice, easy one. If I plug in 1, it says -1. If I plug in 0, it says -0. But -0 is just still 0. There's no such thing as really -0. If I plug in -1, so I've got -1. 2 negatives make a +1. And then I almost forgot, this first one. This one is, look at that symbol, closed. Big open, big closed circle. Next one, plug in 1. This time our function is 2 times that plus 1. So 2 times 1 is 2 plus 1 is 3. Stop there. Don't want to forget this one, first point. That symbol says this is a big open circle. Okay, now we plug in. 2 times 2 is 4. 4 plus 1, 5. 2 times 3 is 6. 6 plus 1, 7. Now I just got to plot them. 1, -1. Right 1, down 1. That's a big closed circle. 0, 0. And left 1, up 1. Use my straight edge. Start at that big point and go in the other point's directions. Okay, next one. Open circle at 1, 3. So big open circle at 1, 3. Then you go right 2, up 5. Right 3, up 7. And start at that big open circle and go in the other point's direction. And there you go. Another piecewise function graphed. What's the domain? Again, my domain is typically going to be all real numbers because I can pick anything less than or equal to 1. I can also pick anything bigger than 1. That's all the numbers. My range, it's here and above. So what is that y value? That's negative. So it's everything above and equal to -1. So why don't you pause the video and try to do 6 on your own, and then we'll compare. There's a fraction, just be careful, but you'll do fine. So pause it, and then we'll compare. All right, so let's see how you did. First one, x is less than -2. That's the 4x plus 5 piece. And my second piece, values that are greater than or equal to -2, it's the 1/4 x plus 2 piece. X, y. Okay, so what value did you have to pick? You had to pick -2 for both of them. And then this one has to be values that are less than -2. So that would be -3 and -4. Now this one you pick values that are bigger than -2. There's also a fraction. So you want to be strategic about that. So bigger than -2. Definitely want to pick 0. I would not pick -1 because that's going to make a yucky fraction. Pick 0 instead. And then what's another value that's bigger than -2 that's going to be nice and easy with this fraction? Remember, if the denominator is 4, I'm going to pick multiples of 4 as well. So I'm going to pick 4. Had to pick -2. That one's not going to be great, but 4 is a great choice because that's going to make the 4's disappear. Okay, Now we just got to plug it in. First, -2 over here. 4 times -2 is -8. -8 plus 5 is -3. Stop on the first one. What is this? This is, look at that symbol, look at that symbol. This one's open. So on the first one, stop, circle it, and highlight it. Is it open or is it closed? This one's open. All right, -3. 4 times -3 is -12. -12 plus 5 is -7. Next one, -4 times 4 is -16. -16 plus 5 is -11. Let's go ahead and plot those points this time. Let's see. So that'd be left 2 and down 3. That's a big open circle. Next one is left 3 and down 7. 1, 2, 3, 4, 5, 6, 7. And my next one's at -4, -11. It'd be right about there. You didn't have to plot that point since it didn't quite make it onto the graph, but I went ahead because it'd be right about there. All right, next one's -2. Okay, so what is 1/4 times -2? Let's write this one down. 1/4 times -2 plus 2. I put the -2 over 1. So what happens there? I get -2 over 4, which reduces to -1/2. -1/2 plus 2. Or 2 minus a half is 1.5 or 1.5. You could have typed that into your calculator. That would be fine. Okay. Next two are easy because I picked values that are convenient for me. 1/4 times 0 is 0, and 0 plus 2 is 2. 1/4 of 4, remember the 4s would cancel, so 1. 1/4 of 4 is 1. 1 plus 2 is 3. Oh, I forgot to highlight this guy. What is that one? That symbol says this one is closed. Don't forget to highlight that. Okay. Oh, I also didn't even connect my points. What am I doing? There we go. Okay. Next. Okay, let's plot that. Left 2, up 1.5. That's a nice big closed circle. And then at 0, we are at 2. And at 4, 1, 2, 3, 4, we are at 3. You might have picked different values, but your line should match up to be about the same flatness. It's a pretty flat line. Okay. Now this one has a weird domain and range. Actually, very weird. So the domain is still all real numbers because we could have picked any x we wanted. The range, however, is very weird. So notice there's a gap. There's no y values here, but there's everything above this one and everything below this one. So this one's weird. Y is going to be, what's that value? That's 1.5. So it's everything above and including 1.5. And then it's also below this value. And what value is that? -3. It's less than -3. That's a weird range. You probably won't see one like that on your assignment. But if you do, that's how you would do it. You separate it piece by piece if there's a gap between the two. The other ones, everything was going in the same direction, right? Up and up. This one, they were going up. This one was going down. So there's a gap between the two of them. That happens sometimes. Again, ask questions if you need to. Google Hangouts is going to work really great for us. We'll get that video call in. I can work it with you step by step. Also, just to give you fair warning, the assignment is all multiple choice, but you really want to practice drawing your own graphs out, because if you don't, when the quiz comes around, you're really going to struggle because you're going to forget how to do it. So please practice it like I showed you. Don't just go through and guess those multiple choice questions, okay? Please do your best. All right, we'll talk to you later. See you tomorrow. Have a great day.